So are any of you familiar with this challenge? Has anybody heard of the challenge? Wow, great. Okay, a lot of you. That's exciting. Glad to hear it. So just to take a step back and talk about the Centennial Challenge program as a whole, this is a program that covers many technologies of interest to NASA for development, and it's basically an incentivized R&D program where different technology challenges are put out. NASA puts together a prize purse and engages with nonprofits and other corporate sponsors to execute the challenges. So obviously this brings forward a group of people with new ideas, which is one of the benefits of that structure, but we've also found we're able to generate a lot of public interest. So for this challenge in the latest phase, we've actually had team videos with over 500,000 views generated as a result of their participation in the challenge. So we do feel that this is a great way to also get the public engaged as well as to move the technology forward. So specifically, the 3D printed habitat challenge has 3 phases. We're currently in the 3rd phase. The first phase back in 2015 was basically an architectural challenge, which did not put a lot of constraints on the designs, but did bring forth a lot of interesting concepts. We wanted to move forward into the more physical printing of mixtures. And so with the second phase, teams were encouraged to develop 3D printers that would use indigenous or recycled materials to print samples of materials, which would then be evaluated for basic parameters like compressive strength, tensile strength. And that culminated with them building these dome structures. You can see one on the upper left. So that structure was printed at the final competition. And we did have a variety of materials printed, everything from geopolymers to more typical cementatious type materials. So we really gained a lot of advancement of the technology out of that program. And where we're at right now with phase 3, which kicked off early in 2018, is challenging teams to participate in one of 2 ways. First, there is a virtual construction competition where the teams can use building information modeling software to basically build a solid model or a 3D model, architectural model of their habitat to meet the requirements put forward by the rules. And they can also then participate in an actual physical printing competition, which will culminate in April, May of 2019. So as we write the rules, I've had the opportunity to work with some really brilliant people at NASA and other sponsors as well to pull together competition rules. So these are the basic parameters. There are obviously a lot more detail behind them, but what we're seeking to have people develop is this habitat to support 4 astronauts for a year. And so again, they can design that virtually, but we also wanted to move them forward in the construction process. So they can leverage the materials that were developed in the previous phase, and they're going to need to scale up their printers to a larger size. And we also noticed that there was a lot of physical interaction with the printers at the last competition. And so we're really pushing the autonomy angle forward. There are a lot of points available in this competition if the teams can basically push go on their printer and have a completed habitat at the end. So we broke that into 3 levels. First, they have to print a foundation. That's complete. The second, we're calling our hydrostatic test. So clearly having a leak-free structure is important if it's going to be a pressure vessel. And so we've devised a test where they're able to print a structure with penetrations through the structure. That's another key thing that we're adding is it's fine to be able to print a monolithic solid, but we know there are going to have to be penetrations for EVAs and other activities. And so that will culminate then with the teams printing their habitat design at 1/3 scale. So it won't be full scale yet, but even these 1/3 scale prints will be on the order of 3 to 5 meters in diameter and potentially 3+ meters tall. So these are some of the things that we've seen as part of this competition. So we already had the first phase of the virtual competition. And so you can see the top 10 entries on the left, very widely varied. They're not all domes. Some of them are domes. Some of them are not. And then on the other side, you can see from the first construction level, these were the foundations that were printed. One of the tests that we had them do was drop a shot put on the slab to check for damage. So we have a wide range of tests to continue to evaluate the materials as well as the capability of the printers to print a high-quality structure. This is a comment from John Vickers, principal technologist, made after attending a civil infrastructure additive manufacturing conference right about the time that we wrapped up the competition phase 2 last year. And I won't read the whole thing to you, but in summary, this 3D printing technology is a real opportunity to make use of the resources that are going to be available where we go, where we need to create a habitat. It's also applicable to Earth. So there's the ability to 3D print structures on Earth and use indigenous materials at the locale where you're printing, maybe structures for low-income housing or things like that. So certainly we've generated a lot of great publicity from this. The teams are the people that really generate the ideas, and so we're just excited to continue to execute this third phase. And if you have any desire to learn more, although a lot of you are already familiar with it, Bradley University in Peoria, Illinois is the allied partner with NASA to execute the challenge. Again, Caterpillar's a main industrial sponsor, and we have several other industrial sponsors as well. So, thank you.
Now I have one. Does this work? I don't know if this does. I'm probably loud enough anyway. Okay, I'm a cargo integration guy on Space Shuttle for over 30 years. So in order to do that 3D printing, I presume that would be like on the moon, you need a way to get your printing stuff there. Was that part of the challenge to compactify the new word?
Yeah,
to package, I guess that's a better word, to package the 3D printing system so that you can actually get it to the moon, and were there constraints that were applied?
Right. So that's something we did consider as we wrote the rules, is would we challenge the teams to have the minimum mass, of their printer, or the minimum package size that you could get it down to. But the more we discussed it, the more we realized that's something that just having the autonomous printing capability to print such a large structure and with these somewhat unique materials was going to be enough of a technology push that we did set that somewhat aside at this time. Although the final competitions are in Peoria, Illinois at a Caterpillar facility, so the teams do need to transport their printers to Peoria over the road. So there is some motivation to keep them portable, but certainly not for launch. Yeah.